Welcome to HB Tuner's Gen 2 Coyote Training Part 26. In this training module, we're going to be exploring how to dial in our speed density tables within our Mustang applications. We have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at dialing in our speed density on our Gen 2 Ford Coyote applications. Our speed density tuning is quite straightforward, but we need to make sure we have a lot of details covered in order to prep your VCM scanner, your logging channels, to allow you to dial in the speed density tables. I'm going to be walking through the entire process here for one single map point, and then we'll talk about what we can do to dial in the other map points. We know we have a lot of map points with our VCT scheduling. So the first thing I want to do is just jump into a calibration file and start to take a look at our speed density tables that we have to work with and talk about how this is actually going to be playing a role in our Mustang applications. So if you are a truck application, speed densities handle in a little bit different way because you actually have a map pressure sensor and you don't have a mass airflow sensor. The Mustangs have a mass airflow sensor, but we don't have a map pressure sensor. But in this situation, we actually have a hybrid mode to be able to calculate what our air mass is going to be between MAF and speed density map-based type of format. And we'll talk about that here in this video of how this actually works. So let's jump in here. The calibration file I'm working with is from my 2017 Mustang GT. I have basic bolt-ons on this vehicle, and technically speaking, I shouldn't have to do anything in terms of dialing in my speed density tuning. The speed density calibration tables from Ford should be valid for this. Now, if I've changed out the intake manifold, let's say to a GT350 intake manifold, that's going to throw off my speed density tables because those were calibrated to my factory intake manifold. Large airflow changes definitely require speed density recalibration. So force induction, for sure, we're gonna have to recalibrate our speed density tables. Intake manifold swaps, throttle body swaps, primarily intake manifold is gonna make more of a difference. We definitely have to redial in our speed density tables. If we're taking a look at, let's say, camshafts, we're putting in different cams in the engine, speed density tables definitely have to be dialed in. If you have basic bolts-on mods, intake, headers, exhaust, you typically do not need to touch the speed density tables. Just for reference sake, I wanted to make that very clear. A lot of people go down the road of trying to dial in all the speed density tables just to find out they made it actually worse. But we're going to look at this process here just because I have this as my example vehicle. I can still show you exactly what to do in order to dial in your speed density tables. So let's jump into this calibration file and take a look at where we can find the speed density section, and let's talk about what we're working with here and how the speed density actually functions and what's going on behind the scenes in our engine control module. So we're going to jump in here to the calibration file. We're going to go under engine, and we're going to move from our general tab here. Let's let this load here for a second. Go from our general tab over here to airflow, and then we're going to move right into our speed density section. In our speed density section, this is going to be combining all the different map points and putting together a whole bunch of different variables to build out this speed density type of calculation. Now, the way this is going to work on our Mustangs, again, if you're a truck application, it's going to be handled a little bit differently, and we'll talk about that in a separate training module coming up. But in our Mustang applications, we have a mass airflow sensor that's fitted to the intake track of our engine. In fact, we've calibrated that already. We understand what that means and how that works. Well, the way this is going to work with the speed density type of calculation is that the mass airflow is registering the airflow coming into the engine, using the mass airflow reading as more of a steady state airflow registration. The mass airflow sensors are excellent at measuring steady state airflow. But the problem is going to be if we get into a transient type of condition where we have a large throttle change and a large burst of airflow entering our engine. The mass airflow sensor can't sample fast enough and doesn't give the engine control module the proper air mass registration in that transient type of condition. And that's where we fall back on this speed density airflow estimation. It's not a measurement, it's not going to be a registration of airflow, it's going to be a estimation. And we're going to be estimating the amount of airflow coming into the engine, and the speed density, because it's an estimation, it's essentially a calculation, it can happen instantaneously. And as long as we've calibrated things properly, it can feed the engine control module an accurate air mass registration in that transient condition. That's why Ford has done this hybrid mode, so to speak, between mass airflow and speed density for our S550 Mustangs. It's for these transient type of conditions. So mass airflow sensors used primarily under steady state airflow conditions, idle, part throttle cruise, wide open throttle where our throttle isn't changing. And then when we're in our transient conditions, that's where it starts to weigh more heavily on the speed density calculations. If you have a vehicle that has poorly tuned speed density tables, you'll find it usually has hesitations, it doesn't feel smooth when you're giving large throttle changes, and that's all a direct result of the speed density not being dialed in. So now that we understand what the speed density is used for, how is this actually working? Because on a Mustang application, we don't have a map pressure sensor measuring how much manifold air pressure is after our throttle plate in the intake manifold. Ford's chose to calculate our map pressure sensor. Now they're able to do that and do it with accuracy based on something called throttle mass flow. Throttle mass flow is when we're able to figure out how much airflow is coming into our throttle plate. And we'll find the F-150 trucks, for example, those are going to be throttle mass flow, speed density. They go about things a little bit different manner. Again, we're going to cover that in that tutorial. But in the Mustang applications, we can solve for a variable that we don't know for throttle mass flow. So for example, in the Mustang application, we have airflow coming into our throttle plate, measured from the air mass.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.